or mode, okay, omega, okay, or median, okay. We didn't use median earlier, but you get the idea, okay. And standard deviation, okay, is used to represent like how wide, okay, how uncertain you are to this central tendency, okay. So the standard deviation work well for normal-like distributions, but okay, if the distribution is not normal-like, what do we do? Okay, for example, it could be skewed. Okay, distribution could be skewed. So an alternative way is to use this one. Okay, we call highest posterior density. Highest posterior density. Okay, another way to call it is highest density interval. Okay, on posterior. Okay, so you know, when you say HPD, okay, of course it must refer to a posterior. Okay, but when you say HDI, it does not necessarily indicate a posterior distribution. But no matter you are talking about HPD or HDI, it must describe a distribution. Okay, it must describe a probability distribution. Okay, so what is this, you know, HPD or HDI? Okay, it is defined. It's defined like as like the shortest interval containing a given portion of the probability density, which reach a certain percentage. Okay, normally we use 95. It's kind of just like you know, remember like if you are a little bit familiar with like traditional statistics, like we used to talk about like a confidence interval, and in the confidence interval we talk about 95 confidence interval, something similar to that. But what is this? Okay, let me show you some figures. Remember here, you remember I mean when I show you these figures, you see there's a 95% HDI on the figure, right? Remember at that time I told you we will talk about this later on, right? Okay, so these are the highest density interval. Okay, HDI represent the highest density interval. Okay, 95% means like, okay, the shortest interval such that when you integrate, do the integration from here to here, you get a 95% of your distribution. Okay, so you know, practically, how do you find it? It is fairly easy, okay? Because we want the shortest interval, right? Because we want the shortest interval. So the higher the better, right? Because eventually we are doing this integral. I mean, we want the shortest interval to get the largest area, right? So the idea is like this, okay? You imagine there's a horizontal line, and you just, you know, move that horizontal line down, okay? And for example here, you move the horizontal line down, it will touch the contour of this distribution at the 2 points, right? Or maybe more than 2, but anyway, you get the idea. So for example, when we touched here, okay, these two, you just do the integration from here to here, then it will give you a portion of this distribution, right? So as you move this line, this horizontal line down and down, okay, the integration of this range will be larger and larger, right? So at the exact time when this portion reach 95, percent. That's the interval that you have for this highest density interval. Okay? If I try to explain HDI, intuitively, that's how you get it. But of course, you don't need to do that. You can just write a program to have the computer to get it for you. Okay? I'm not saying you have to, really draw a horizontal line to do this. Okay? And you can see, remember what I told you? If you're talking about the HDI, it has to refer to a, distribution, right? Okay? So you can see we draw the HDI on the prior and the posterior. We didn't draw HDI on the likelihood, right? Why not? Because likelihood, remember what we discussed earlier, likelihood is not a distribution. Binomial distribution is a distribution when you use y as like the x-axis. It's a discrete distribution. But if you use theta as a x-axis, it's not considered as a distribution. Okay, and if you use HPD, okay, then HPD can only be used for posterior. So these two are 95% HPD. But you cannot say, oh, that's HPD. No, because that's not a posterior. Okay? Just want you to get an idea. Okay? So this HDI or HPD is another indication on how dispersed or how concentrate, okay, your distribution is to that central tendency. Okay? If your interval is narrower, that means you are more confident that the data is at the center. Okay? Something like that. Where are we? Okay? So, yeah. So we normally do 95%, but we could do other percentage as well. Okay. So according to our data model, we think the parameter in question is between 2 and 5, with a probability of 0.95. That's like a 95%, HDI or HPD. So there's nothing special about choosing 95%, 50%, or any other value. Okay, they are just arbitrary, commonly used values. But 95% is the default value. To be honest, I mean, we use 95% the most. Okay, ideally, justifications should be context dependent and not automatic. So remember, I just told you we can use like a package to obtain the posterior and also like to find the HPD for us. Okay, so the RVs is the Python package that can, we can use for like a Bayesian analysis, and RVs, I mean, one of the functions in RVs, which is az dot posterior. Okay, basically like can draw the posterior for us, and it will also generate the mean and the HPD of the distribution, okay, for us. And this is an example, okay? And you can see the mean is specified as 0.3 here, and the HPD is indicated as from 0.1 to 0.5. But this HPD is 94%. Interestingly, okay, RV's package, the default HPD is 94%. It's not 95%. Don't ask me why. Okay, I don't know why, but you could reset this percentage to a different value. Okay, the default value is 0.94. So you can change this by passing a different value to this credible interval argument. If you want 0.95, I mean, which is what we normally use, okay? So you just pass that argument. I mean, with this, with this, pass this value to this with this argument. So highest posterior distribution interval, okay, is not confidence interval. Previously, I just told you, okay, it's kind of like confidence interval, but they are really not the same. They are very different. Confidence interval is used by frequentists, okay? The concept is based on the p-value, okay? And for highest posterior density, or HDI, okay, if you want to say it like that, basically, okay, it's a very, very simple idea, okay, to describe like the most probable interval for distribution. It has no any particular prior assumption, okay, when you when you obtain this highest posterior density, or HDI, okay? So HDI or HPD are more intuitive and without a lot of assumptions, so it's easier. And then it's the following is the posterior predict check, which is like to verify the model result makes sense, but because I will have like a lunch appointment with like a speaker, so I probably cannot finish this slide. Okay, we still have how many slides? Yeah, I don't think we can finish that. We have like 7 slides left, but we should be able to get it done like maybe like another 15 minutes. So I will finish this up, this chapter, okay, next time, and start a new chapter. In our next week's lecture. Okay. So any question? If no question, that's it for today, okay? And I will see you in a week then. Okay, thank you.